Hello and welcome to this talk at DEFCON 30. This talk is pre-recorded, so in case there is some misalignments of the slides, in case I might have adjusted them later on, just have a look and follow them. Where you find them will be somewhere in the text around here, so have a look at them as well while following the presentation, because there might be some updates until then. Okay, so let me start. Welcome. I'm Patrik. I'm a maintainer at Ori, open source maintainer, doing other stuff than open source as well, obviously, but currently my main project is Keto. So it is a open source implementation of Google Zanzibar, in case you heard that already. So basically it is a authorization server that's highly flexible and highly performant. I'll tell you more details during the talk, but I first want to introduce myself. So I'm originally from Germany, and there I work at Ori full-time, and we today want to look into basically how a open source zero trust election backend could work. I know we talk a lot about voting machines here, so for me this is a bit of a foreign topic, because let me quickly give you some background on what we have in Germany regarding digitalization of elections, basically. So what we have is, in our constitution, there is basically a principle of publicness. So during elections, this basically means during elections, all essential steps of the election and result derivation must be reviewable by the citizen without any special expertise. And this in turn means that voting machines can't be used because they don't provide the necessary transparency. This whole principle of publicness can basically be summarized, I can give you some examples what that means. So during elections, anyone is by the constitution allowed to go to the voting locations, see what people do there, election workers as well as voters, obviously not disturbing the election process in any way, obviously not looking at what people actually vote, but they can see, do they properly check identity cards, because that's something you have to do in Germany. You have to show your ID when going for voting. They can basically check all the steps, and they have to be allowed to do that. And this applies also to citizens who are not allowed to vote, or even non-citizens of Germany. So anyone could just go there and say, I want to watch this, I want to observe this, and by constitution they have to be allowed to do that. They could also, during the counting process, just attend the room where it's done. Anyone could just go there and basically see how do they count the votes, how do they process them. And basically because of this, by constitution, we can't use voting machines. However, what we do have is a digital system to basically accumulate all the votes. So in each polling location, what they do is they count all the votes they have by hand from paper. And then once the total numbers are fixed in the location, they use digital tools to transfer those votes up the chain to the next highest, basically entity. So there is a few levels before it reaches the final result, and this accumulation, obviously also before digitalization, wouldn't be very transparent to anyone observing. So it doesn't really matter if they tell the numbers, if they tell them through a phone, or if they just type them into a computer and hit submit. So this part can be digitalized and actually is digitalized. So there is a few pieces of software that are used for doing these accumulations, and I think it was 2016, so around the first Trump election, where there was a lot of rumors about Russian hackers affecting or messing with elections. The German CCC, which is basically like similar to the EFF here in US, they did some analyzation or some review of of one of the software that was used for this voting, this vote accumulation. And basically they discovered significant flaws. There was a lot of funny stuff, like for example keyless encryption, which you might wonder what that means. It's just encryption that works without a key, so anyone who reverse engineers the algorithm can encrypt anything. We had FTP credentials that were shared for all users. The FTP server was only accessible through a VPN, and that VPN had very weak access credentials, so the username test and password test would just work and get you into that. The overall problem with that VPN and intranet was also that it was used by many institutions and companies at the same time. So we had contractors, we had the companies running the infrastructure, and all of them, also election workers, officials, all of them had to have access to that intranet. And basically, because of that, a lot of credentials were shared. There was a lot of people who had access to this, and it wasn't really clear who had access because the credentials were not scoped to specific users, but really used by many people at the same time. So yeah, that's, I mean, there is a very detailed report about this. I recommend reading that one because it's really, I'd say it's funny to read if it wasn't true, but it is true, so it's not that funny if you think about it. Okay, and then I looked at how is this actually done in the US or in other locations. How are the votes accumulated? Doesn't really matter how you count the votes in the end, if you use a digital voting machine or if you use pen and paper. At some point we have some numbers that we input into a computer and transfer up the chain to the next highest official. And I found some documents, I found some drawings, some schematics and network topologies of various sources. So basically, I found a very common pattern, and basically all of them, all of the documents I found described a similar pattern. Was that we had this very classical corporate structure. So basically, we have a firewall that's protecting the vote count server. That could be many servers, that could be database, server, many different entities. I'm just abstracting this away because it doesn't really matter for this case. We have the firewall that protects basically the trust zone. Anything that happens within the trust zone is expected to be trusted. So there is nothing really happening within that. Once you're in there, you're in. So the single source of security here is our firewall. And once this backend is compromised, we basically have a very hard time to actually contain the attack and ensure that no misuse happens. And typically that's what is used most of the time in US, Germany, whatever. And there is several problems with this. I will point out problems that are specific to basically elections, and this pattern is commonly used in many places, and I'll talk about this mainly in the context of elections, but this obviously is also true for corporate networks that are protected the same way. So one of the problems we face, as I already said, is we have many stakeholders. So we have election workers in the polling location who have to access the server and submit the result in the end of the day. We have contractors that run the infrastructure. We have contractors that run the software. We have officials that are higher up in the processing hierarchy and basically need to get all the submitted results, have to compute them, accumulate them basically. And what we mainly don't have with this kind of system and this kind of architecture is audit logs of what actually happened. So one problem is if all the locations, as it was in Germany the case 2016, use the same credentials to log into the system, I could, if I were the election worker in one location, transmit a result for another location as well. I mean, it will probably be noticed by the ones in the other location, hey, we didn't transmit or submit a result yet, why is there one? It's not correct, and they would correct it. But still, there is some problems with this. The underlying issue, of course, is if we mess with this whole system, then we lose credibility, and basically if someone was able to mess with the first result that's published, and then an hour later a corrected result is published that's completely different from the first one, people would be suspicious of what's going on, what's happening there, is someone messing with our elections, and it's not a good thing to happen basically, Then another problem we have is we need a proof of correctness. So if we were to just store our results in some database and someone would mess with the database, change results, we would need to notice this. And as I said, it works kind of in a way that I can verify the result I submitted as an election worker is later published as well. So this is the best we can do basically with this kind of backend. But still, we cannot lose any evidence, and we have to have a valid evidence of what was actually the result, and no one should be able to mess with that. So in case we talk now about voting machines, if someone were able to hack into a voting machine, change the result inside there, if it was completely digital, we would have no proof of correctness. We wouldn't know if someone messed with it and changed the result actually. So this is something we have to always keep in mind. And then we also need basically goes hand in hand with what I just said, a tamper-proof source of truth. So basically something that no hacker would be able to tamper with. So we can really keep the source of truth and know the result will not be lost in the end. Okay, and then one last problem we have is basically, oh, it's not the last one, sorry. We have a very short time of high traffic, so basically the election, when it's happening, it's a very short time and there is a lot happening during that short time. So this could also be a way for an attacker to abuse, is basically just take down the whole system because it wasn't kind of denial of service, because it wasn't built in a way to handle the high traffic, and there is a pretty high traffic already on it with legitimate use. So this could obviously also go wrong in a way that legitimate use would cause a denial of service. So this is something to keep in mind, that basically during preparations for an election we will not have the same traffic as during the election as well. And then one last topic is that we have limited administrative capacities. I mean, the whole point in why VPN credentials might be shared and why this whole system isn't set up in a very secure way is that no one from the election officials will sit down, create accounts for every election worker, give them some password, bug them into changing that default password or whatever it is, set up email addresses for them to use or just collect the email addresses they already have. So that's why basically in the first place the credentials are reused, and why it is the way it is. So that's also something to keep in mind. It should be very simple to set up an election and to reduce the barriers for officials, because otherwise they will not use the security that we might think of they should use. Okay, so how would an ideal backend look like? The very first and most important part is it should be open source. Obviously, me as an open source maintainer will say it's important, but there is a lot of points that we have to think about, and that open source software can give us and guarantee that proprietary software will never be able to guarantee. So with open source software, we know it can be peer reviewed. If it's in use already for a longer time, if it wasn't just written 2 days back, it is probably peer reviewed. If there's other companies using it, they will run security checks against it. I can tell from our open source work, we regularly get emails about basically vulnerable dependencies used. So basically people run scanners themselves, they analyze what we publish, they notify us about, hey, our scanner found this vulnerability that is used in your software, can you give out a security patch? So we actually know people are doing this actively, and it's something that really can bring trust to this whole software system. So we can give a lot more trust, like generally, into open source software and security of open source software than proprietary software, because it is open. Anyone can look into it. Anyone can verify it's doing what it's doing. There is a very, it's basically impossible to implement a backdoor in an open source system and have it there for ages. It might be possible to do it for a very short time, but it's not possible and feasible to maintain that for years, if it's not a 0 day, of course. So yeah, generally speaking, complex systems are always hard to verify. So obviously you don't want to build it yourself. You should rely on the experts to build it for you, to give you a working system. And in general, with open source, we can actually also run our own Q&A, so we can so basically we can do our own quality assurance by hiring security researchers, giving them the resources to analyze what we want to use, and basically be confident that it's not halfway bad, at least. Obviously, you will always have some vulnerabilities left. There is no such thing as 100% secure software, but obviously if you use keyless encryption, that's a different story, and that shouldn't be in there at all. And you should, for example, also protect software updates with cryptographic signatures, so no one can patch software that they're not supposed to be. And this is just common security best practices that we can ensure are definitely met. Right, and then generally speaking, with open source software, we also have advantages that anyone can audit it, and it's reproducible for anyone. You can just run it yourself, so it's not something like you would have to buy a license key first, and it's hard to get to the software itself because you first have to sign a contract, but you can just run it, you can just get it, download it, inspect the code, you can just see what's happening, and this is basically all building trust. And this is also something that can be communicated, so you can say, hey, we use the open source software, go see for yourself that it's secure, and then people can trust in the overall election system much better. So another very important point is that we don't, with open source software, we can reduce dependency on one entity. I mean, maybe not completely remove it, because security patches and updates probably still need to be delivered by the core team. But if the company or the team would just vanish or the project would be abandoned, we still have all the code, we can still work on it ourselves, and there is no problem with basically a lot of dependency on one entity. And then one last, I think, important topic is basically we take public money, we take tax money, we put it into a software, we buy something, and then that software is just gone into the private sector, and there is no basically no, like, you use it for a single election and then you're done. And I think that's not really how public money should be used, but instead, if there is something bought by tax money, the code should also be public. Okay, so this is basically why I think an ideal backend would be built completely on open source software. So the next topics for the ideal backend are, we need some kind of paper trail for records. There is probably no other way to provide a tamper-proof source of truth other than paper. So it doesn't really matter how you do it. If you want to print the results before you submit them, if you want to count the votes by hand from paper, that's not really what I care about here in the backend, because in the backend I just want to make sure there is some paper trail that holds the source of truth, and we can rely on that just being present. Obviously, what we also want to have is cryptographic signature of submission. So even if some attacker were able to get into our backend, we don't want them to be able to just create submissions. They would have to gain also access to the cryptographic keys to do so. We do want modern authentication. So this means no sharing of credentials, ideally 2FA, ideally using some kind of secure second factor like WebAuthn with YubiKeys, so these security keys. That would probably also help in reducing the barriers for the probably not so technical election workers. If they just have to plug in a key, it reads their fingerprint and makes them log in together with a password, it will be a lot more acceptable for the people that actually work with this system. Then what we also need is fine-grained authorization. So we want to assign the least privileges possible to all the people who have access to the system. It shouldn't be able for anyone to, for example, submit or do stuff they're not supposed to do. And this should also come with audit logs and ways to verify what was happening, and basically ways to tell that misuse was happening. So overall, we want a zero trust model that ensures all requests are authorized, authenticated, and there is no once you're in there you can do whatever you want, but instead we want to really contain breaches and not rely solely on the security of the firewall. And then as a last point, we want also the 12-factor principles. So this is also an important part for basically we want to be independent of contractors. So if you're logged into some cloud system, you might be in a bad spot if that system goes down. You might want to run an election on a multi-cloud service or on your own premise, possibly. So that depends a bit on the use case and the requirements, of course. But yeah, we want a declarative and therefore reviewable configuration that ideally is also published and publicly accessible, so you can prove that no one is able to mess with the system. And the 12 factors principles will also ensure that performance during bursts, so during the election process, is not a problem. So we can just scale easily, we can add more resources, and the system should still work. So I have sketched out basically from all of these points a proposed backend, and for me, of course, as the maintainer of Keto, the important part is here the authorization with Keto. But I can quickly walk you through what this whole slide means, or the sketch means. So obviously we have all the voting locations, and they connect to our API gateway just through normal public internet through HTTPS. There could be a VPN in place that just helps in preventing denial of service from the outside, but that's kind of optional. Depends on the use case again. And the first thing that happens is the API gateway authenticates the request with some kind of identity server. Here we could use, for example, something like Oracle, which is just an identity server, but that's probably not the ideal scenario. We would probably rather use something like Orihydra, so a federation service, which allows us to sign in with multiple identity providers, like the contractor's single sign-on page, or this government's officials intranet page, or whatever it is. So when the request is authenticated, we get back the identity information, and then the API gateway can do the authorization with Keto. And the nice thing here is that basically, Keto as I said, in the ideal backend, it is open source, it follows 12-factor, it works independent of any identity server. So basically all we need is some identifier of the user, and then we can just look up whether that identifier, that user, is allowed to do the action they are trying to do. And we can do here very fine-grained permissions. So this all is, as I said, an implementation of the Zanzibar paper. So we can do very fine-grained permissions. We can work basically on on anything. It's very flexible. I would love to go into the details here, but time doesn't allow that. And then basically, after we've authenticated and authorized the request, we can forward it to the actual backend. And yeah, this is basically all of the internal network is only accessible through the API gateway. There is MTLS used, so even if an attacker was able to get into some of the internal network somehow, only we can set up network policies to restrict communication. We can ensure that communication is only happening as it should be, and with MTLS we know that, or I mean any other system obviously would work as well, that authenticates the microservices against each other. So yeah, basically this is a backend that would be very flexible and would meet all the demands and all the requirements I presented. So we also did prepare a small hacking challenge. There will be all the details on that GitHub repository, and you can go to our Slack and reach us, or just through Discord, as we do here on DEF CON. And you can also, if you found some vulnerability during that challenge, submit it through HackerOne and be part of our bug bounty program. But yeah, all the details will be on the GitHub repositories README, so just go there, enjoy, have fun. Thanks a lot for listening. I really enjoyed giving this talk, and for everyone here in Las Vegas, see you and have a nice day. Bye.